So it says a caravan was bought for £20,000. It depreciated by 11% in the first year. It then depreciated by a further 6% each year over the next 2 years. Calculate the value of the caravan 3 years after it was bought. So because it's a depreciation question, we start by doing 100 minus 11, and then we divide it by 100, and that gives us the factor of decrease. So it would just be 0.89. And then we multiply that by 20k to get the value after the first year. So that value would be £17,800. So that's how much it costs after the first year, how much its value is after the first year. And then we're told it depreciates by a further 6% each year over the next 2 years. So a depreciation, so I'll just draw a line there actually. And then we're now going to calculate how much it would cost after the next 2 years. So a depreciation of 6% would have a factor of decrease of 0.94. So 94 over 100, that's 0.94. And then because it's depreciating for 2 years, we would just raise that to the power of 2. So 17,800 times 0.94 squared, and that gives 15,728.08. And that's the value after 3 years. Okay, question 2. The mass of a helium atom is 6.64 times 10 to the minus 24 grams. A flask contains 300 grams of helium. Calculate the number of helium atoms in this flask. And then it says give your answer to 3SF. Okay, so this is the total weight of the atoms, the total mass of the atoms. And then this is the mass of one atom. So to get the number of atoms, we would just do 300 divided by 6.64 times 10 to the minus 24. And that would give us one atom. So I'll just get the calculator. So it would be, so you press this button to get fraction notation. And then you press the right button. And then 6.64 times 10, and then the power button, and then minus 24. And that actually gives you it in scientific notation. So it would just be 4.552 to 3 significant figures times 10 to the 25. And that wouldn't have any units because it's a number, the number of atoms. Okay, question 3. The diagram shows part of a football pitch. The penalty spot is marked at point C. AB is an arc of a circle, center C, radius 9.15 meters. Calculate the length of the arc AB. So the arc AB is just this arc over here. And we simply use the arc length formula. So AL equals, and then it would be theta over 360 times the circumference of the circle, which is just 2 pi r, essentially. So that would be 106 over 360 times 2 pi, and then times 9.15. That's the radius. And then to do that on the calculator, we'll just get calculator. So that would be 106 over 360 times 2 pi, and then shift pi to get the pi symbol, and then times 9.15. And then you just press SD to convert it to a decimal, so it would be 16.927 and so on. So we'll just give it to one decimal place, so that would be 16.9 meters. The diagram shows triangle JKL, and then we're given some information. Calculate the size of angle JKL. So since we don't have the angle between the sides, that means that this is a sine rule question. So let's start by labeling the sides. You can do it without labeling them, but I'll just show how it's done using the ABC notation. So that would be, we're trying to find side C, so it would be C over sine C. No, we're trying to find angle JKL, sorry. So that would be angle B, because it's opposite side B. So sine B over B equals, and then the information we have is the side A information. So sine 25 over 7. So we can just write the formula first, actually. So sine A over A. And then if we plug in the information, that would become, so B is 10, and then angle A is 25, and A is 7. So that gives sine B equals, and then we just multiply both sides by 10. So that would become 10 sine 25 over 7. And then we just enter that into the calculator. So 10 sine 25. And you make sure you're in degrees mode, because sometimes it might be in radians mode for whatever reason. So that would be 0.603 and so on. So that's the value of the sine. So I'll just write that over here. So 0.603 and so on. And then you would just take inverse sines of both sides. So you just do, you press shift and then the sine button, and then you enter the answer that we just got. And that gives 37.1 degrees. So I'll just write it up here. You shouldn't do this in the exam, by the way. It's better to use more paper, but I'll just write it here. So B equals inverse sine of 0.603 and so on. And that gives 37.1 degrees. A logo consists of an H shape and a regular decagon. The diagram represents the logo. Calculate the size of the shaded angle. So the shaded angle is this angle over here. I know it's not clear from the diagram. So that's the angle we're trying to find. And we know that this is 90 because it's a right angle. So we just need to find this angle over here. So given that this is a decagon, it would have 10 angles, and you can just count them if you want to. So we would just do 360 divided by 10 to get one of these angles. So each one would just be 36 degrees. And then that means, so we've got an isosceles triangle. So these sides are the same, they're just these sides over here. And this angle is 36. So to find these angles, it's just 180 minus 36 over 2. And that would be 72 degrees. So each one of these is 72. So that would also be 72 over here. And then we've got a straight line. So this is a straight line. And we've got, so these two angles are each 72 degrees. So essentially we've got a straight line, and then we've got one 72-degree angle, and then another 72-degree angle. So this angle, which is this one here, would just be 180 minus 72 minus 72. And that would be 36. So it would just be 36 plus 90, which is 126. Nadeem bought a flat last year. The value of the flat has increased by 8%, and it is now worth £94,500. Calculate how much Nadeem paid for the flat. Right, so we know that after an increase of 8%, it is now worth 94.5k. So that would mean 108%, which is just 100 plus 8, is 94,500. And then we divide by 108 to get 1%. So that would be 875. And then we times by 100 to get the original value, which is 100%. So that would just be 87,500. Change the subject of the formula P equals that stuff to M. Okay, so I'll just write out the formula. So we start by moving the R to the other side, so that would give P plus R equals 1 over 3 Mn. And then we multiply both sides by 3, so that gives 3P plus 3R equals Mn. And then that gives, if we divide by N, that would give 3P plus 3R over N. A wooden beam is used to support a wall built on horizontal ground, as shown in the diagram. The edge of the beam AB is 8 meters long. And then we're told that C is the foot of the beam. And then A is 7 meters from C, B is 4 meters from C. Determine whether the wall is perpendicular to the ground. So this is just an application of the converse of Pythagoras. So we don't know if this is a right angle at this point, and that's what we're asked to determine. So in order to find out if this is a right angle, we would just apply Pythagoras's theorem. So essentially we assume it is a right angle, and then we see if that works. If it doesn't work, that means our assumption was wrong, and that can't be a right angle. So if we apply Pythagoras, that would just give 7 squared plus 4 squared, and then we put a question mark, because we don't actually know if Pythagoras holds. and then we write 8 squared. So this side would give 65, and this side is 64. So that means the two sides aren't equal, meaning Pythagoras doesn't hold. So this isn't a right angle. So to answer the question, the wall isn't perpendicular to the ground because that isn't a right angle. Isn't perpendicular to the ground. A concrete block is in the shape of a large pyramid with a small pyramid removed. The large pyramid and so on. The block has height 60 centimeters. Calculate the volume of the block. Okay, so we're trying to find the volume of this block over here, which is basically a 3D trapezium kind shape. So we just need to find the volume of the large pyramid, and then we would subtract the smaller pyramid's volume from that. So we know that the total height is 108 centimeters. So that's the height of the large pyramid. And the cross-section area of the large pyramid is just 90 squared because it's a square-based pyramid. So that allows us to find the volume. So it would just be a third. I'll just write big V for the big pyramid and then little v for the little pyramid. So it would be a third A times H. A is 90 squared. We'll just use brackets, so 90 squared. The height is 108 centimeters. So let's get the calculator out. So 1/3 times 90 squared times 108. So that's the volume of the large pyramid, 291,600. And then the smaller pyramid would be a third, and then the base is 40 squared this time, the base area, and the height is 48 centimeters. So that gives 25,600 centimeters cubed. So the block, I'll just write V block for that. V block, that would be big V minus little v. And that gives 266,000. Express 7/x minus 3 minus 2/x as a single fraction in its simplest form. So we can just cross multiply to simplify the fraction, and that's known as the kiss and smile method, because this is the kiss, this is the smile. So you basically do 7 times x minus 2 times x minus 3 all over x times x minus 3. And that gives 7x minus 2x, so that's 5x. And then minus 2 times minus 3 plus 6 over x times x minus 3. Question 11. Anna has a grandfather clock in her house. We're given a formula for the height of the tip above the ground. X is the angle it's rotated since 12 o'clock. Calculate the first two values of X for which the tip of the hour hand is 150 centimeters above the floor. Right, so because this formula represents the height of the tip above the ground, then we just need to set h equals 150 centimeters. And then we would just solve to find the angle, the first two values of x that give this height. So 150 equals 20 cos x plus 147. And then we subtract 147 from both sides. And then we divide by 20. And then we just find the inverse. I'll just do that on the calculator. So shift and then cos button to get the inverse function, and then 3 over 20. So that would be 81.4 degrees. That's the initial solution. And then you just draw your cast diagram. And then we'll just find the second solution. So 81.4 would be in this quadrant. And then the equation is cos x equals 3 over 20. So that's a positive value of cos. That's positive. So the quadrants where cos is positive are this quadrant and this quadrant. And you should actually check that before drawing the initial angle, by the way. So that was a mistake when I drew the angle before checking the quadrants. So it's this quadrant and this quadrant, and then you just draw the angles in that quadrant. So the angle is 81.4, so both would be 81.4. And then you just measure each one from the initial line. So this line over here is called the initial line. So you just want to measure each one from that line. So the first one would be 81.4. So that stays the same. And the second one would be all the way around like that. So if we go all the way around, that would be 360. So up to here, it would just be 360 minus this angle. So the second solution is just 360 minus 81.4. And that would be 278.6 degrees. So those are the two solutions. The first two values of x for which the tip is 150 centimeters above the ground. Simplify x squared minus 16 over, and then we've got a trinomial in the denominator. So x squared minus 16 is just x minus 4 times x plus 4, and that's the difference of squares factorization. And then we just factorize the quadratic as usual. So two numbers that multiply to give minus 20 and add to give 1. So that would be 5 and minus 4. And then we just simplify by cancelling the common factors. So we get x plus 4 over x plus 5. simplify 2 sine squared x plus 2 cos squared x. So we can just start by factoring out the common factor. And then we know that sine squared plus cos squared is 1. So that's just 2 times 1, which is 2. A storage unit built in the shape of a cuboid is shown. It has length x plus 7 meters, breadth x meters, and height 2 meters. The volume of this unit is 45 cubic meters. Show that, and then it's got a quadratic equation. So we know that the volume is 45 meters cubed. So if we multiply all of these dimensions, that would give us 45. So x plus 7 times x times 2 is 45. Now this expands to give, so 2x times x, that's 2x squared. And then 2x times 7 is 14x. And then equals 45, so we can just move the 45 over, and that would be minus 45 equals 0. So we've shown that this equation is true. And then part B says calculate x, the breadth of the storage unit. Give your answer correct to 1 decimal place. So whenever it says give your answer correct to, and then it's got some kind of approximation, that means that you have to use the quadratic formula. So the formula is x equals minus b plus or minus root b squared minus 4ac over 2a. And then we just plug in the coefficients. So b is 14. So it would be 14 squared, that's 196, minus 4 times 2 times 45, minus 45. So that would be plus 360. Let me just write it out. So 14 squared minus 4 times 2 times minus 45. Those are the values of A and C. And then it's all over 2 times A. So A is 2. And then we just simplify that using the calculator. So this just means that you take plus first, and then you take the minus sign when you enter it in the calculator. So I'll just put the plus sign to begin with. So minus 14 plus. So minus 14 plus root 14 squared minus 4 times 2 times minus 45. And then it's over 2 times 2, which is 4. So that gives this number. And to 1 decimal place, that would be 2.4. And it would be in meters. And then to get the other solution, we just press the left button to get back to this part. And then we delete the plus sign and we change it to a minus. And that gives minus 9.4. And because that's a negative number, we know it can't be a physical dimension. You can't have a negative length. So this solution is invalid, and then it would just be 2.4 meters. Okay, question 15. In the diagram, AC is perpendicular to BC, and then we've got these lengths in the diagram. And then we're told that the area of the triangle ADE is 160 square centimeters. Calculate the length of AE. So we're trying to find this length over here. So whenever we're given the area of a triangle, it's likely that we're going to need, especially if it's the calculator paper, it's likely that we're going to need this formula for the area of the triangle. So if we can find sine A, so for this angle, the formula would just be half and then AE, so this side times sine of the angle between them. That's what this formula is, essentially. So it would be this side times AD times sine A. So that means, let's just plug in the information we have. So we know the area of the triangle is 160. So A is 160. We also know that AD is 24, 18 plus 6. So that's 24. And we don't know sine A or AE. And we're actually trying to find AE. So let's find sine A to begin with. So we have this side is opposite to this angle. So that would be the opposite side. And this would be the hypotenuse. So in terms of sine A, we can just use SOHCAHTOA to get opposite over hypotenuse, SOH. So that would be 8 over 18, which is 4 over 9. And that gives us sine A. So this becomes a half 24 times AE times sine A, which is 4 over 9. And then we can actually just cancel the 2 from the 4. So that becomes 2. And then we can just cancel the 9, the 3, and the 24. So that becomes 8. And we end up with 160 equals, and then it would be 8 times 2 over 3. So 16 over 3 times AE. And that gives AE equals 3 times 160 over 16. So we just times both sides by 3, and then we divide by 16. So 3 times 160 over 3. Over 16, sorry. And the 16s actually cancel to leave you with 10 in the numerator, and that would just be 30 centimeters.